Hello friends, I am Dr. Sangeeta Patil, Assistant Professor in the Department of Electrical and Electronics Engineering, MIT School of Computing, MIT ADT University. Welcome you all for a course on Basics of Transformer. Let us start the lecture. We know that there exists some fixed relationship between the voltages and currents in primary and the secondary windings of the transformer. So, by taking into account this relationship, it is possible for us to simplify the equivalent circuit of the transformer that I have taught previously by transforming the voltage, current and impedance on one side of the transformer to the other side and eliminating the transformer winding which are representing the ideal transformer. So what do you mean by transforming or transferring? Transferring means we have to substitute these quantities in one circuit by their equivalent quantities in the another circuit. Thus, after such transfer, all the resistances and reactances can be assumed to be concentrated on only one side of the transformer. So let us study how to transfer the quantities on one side of the transformer to the other. Firstly, we will consider that we will transfer all the secondary quantities to the primary side. So student, we have studied one factor or ratio which is nothing but K. What is K? K is nothing but the transformation ratio. We have studied what is transformation ratio. Transformation ratio is nothing but ratio of secondary EMF to the primary EMF or secondary turns to primary turns or primary current to the secondary current. Or in terms of voltages also we can write down it as V2 upon V1. So transformation ratio, according to the value of the transformation ratio, your transformers are classified as step up transformer, step down transformer or 1:1 transformer, right? That we have studied. So if K is the transformation ratio of the transformer, then I can write down the primary equivalent of secondary EMF E2 as, means if my E2 is transferred from secondary side to the primary side, then I will denote it with the E2 dash. That is equals to E1 equals to E2 by K. Simply from the equation number 1. Simply from this equation number 1. So the primary equivalent of your secondary EMF E2 I can write down as E2 dash equals to E1 equals to E2 dash by K. Let this equation as equation number 2, right? And similarly, I can write down the primary equivalent of secondary current I2 is, we have seen that I2 dash equals to K into I2. Right? Means if I2 is transferred on the primary side, what is its equivalent current? It is I2 dash. So it get multiplied by your current I2 on the secondary side. If you have to transfer on the primary side, it should get multiplied by K. From above two equation, therefore, I can write down primary equivalent of the voltage drop I2 R2 due to secondary resistance. In short form, I will write down this secondary as like this. Secondary resistance as equals to I2 R2 by K. But what is my I2? My I2 from this equation is nothing but I2 dash by K. So I will write down this as I2 dash by R2 divided by K into K, or simply I can write down it as I2 dash upon R2 by K square. So the term R2 by K square, so the term R2 by K square in above equation is nothing but equivalent resistance of secondary winding referred to primary side. Equivalent resistance of secondary referred to primary winding, right? And it is denoted by R2 dash as it is transferred. If I am transferring R2 on primary side, it will become R2 dash, which is equals to R2 by K square. Let us give this equation as equation number 2, this equation as equation number 3. Similarly, the equivalent leakage reactance of the secondary side, if it is transferred on the primary side, I can write down X2 dash equals to X2 divided by K square, similar to that of your R. We can deduce this relationship. So let this equation as equation number 4. So in the similar way, the equivalent load impedance referred to the primary side, I can write down as, let ZL is the load impedance. So when ZL is transferred to the primary side, it will become ZL dash, and that will be equals to ZL divided by K square. Give this as equation number 5. The primary equivalent of secondary terminal voltage. The primary equivalent of secondary terminal voltage, it's denoted by V2 dash, which is nothing but again equals to V2 upon K. It is similar to that of this equation only. Equation number 2. Thus, after transferring all the secondary quantities to the primary side and totally eliminating the transformer windings, which are representing your ideal transformer M, in the equivalent circuit of the transformer that I have taught you in the previous lectures, can be drawn as follows. So let us draw the equivalent circuit after transferring all the secondary side quantities on the primary side. So let us draw the equivalent circuit. So primary resistance I will draw as it is then inductance, primary inductance, leakage reactance as it is. Then after this there is a shunt circuit which is consist of your R0 and X0 that we have to draw. So here is your R0 of the shunt circuit and this is your X0 of the shunt circuit, right? Then like this your primary circuit will get closed. Right? Here you have applied the voltage V1. What is this? R1. What is this? X1. Current taken from the supply is I1. Current flowing through the shunt circuit is nothing but I0. Now, let us consider the secondary side. We have to eliminate the transformer winding. Means we have to eliminate the transformer winding which are showing us the ideal transformer. Now we have transferred all the quantities of the secondary side on the primary side. So just after this shunt circuit, I will draw the resistance R2, leakage reactance X2, and simply I will connect load here. Like this is your X2, this is your load, this current is nothing but secondary current referred to the primary side, and this one is the voltage across the load. When that voltage is transferred on the primary side, it will become V2 dash equals to V2 by K. This will become R2 dash, which is nothing but R2 by K square. This X2 will become X2 dash, which is nothing but X2 by K square. Let ZL is the impedance of the load. So when it get transferred to the primary side, it will become equals to ZL upon K square. Current flowing through this R0 is IC. Current flowing through X0 is I magnetizing. This current is I2 dash up to this, and again phasor addition of your I2 dash and I0 is I1. And now one quantity is remaining, that is nothing but your this. What is this? This is nothing but, 1 minute. This is nothing but E2 dash, which is nothing but equals to E1. So this figure shows you the equivalent circuit of the transformer referred to the primary side. Students, transformer calculation can be simplified by moving this shunt circuit, which is consisting of R0 and X0, from the middle to the input terminals of the circuit. Means before R1 and X1, I will shift this shunt circuit. If I move this shunt circuit before the R1 and X1, a small error is introduced because we have to neglect the drop in the primary impedance of the winding, which is causing due to the no load current. It means that we have to neglect the drop in the primary leakage impedance caused by the no load current I0. And as we are neglecting this error, if I transfer this shunt branch in the front side, then this circuit will become the approximate equivalent circuit of the transformer. So let us draw the approximate equivalent circuit of the transformer referred to the primary side. So let us again draw this circuit by transferring that shunt branch. Then I will draw here the resistance, leakage reactance of the primary winding. Now what we have to do? We have to transfer this shunt circuit on the input side, means before R1 and X1. So see how we are doing. So just I will add one shunt circuit here. Right? This is your X0, R0, current flowing through this IC. This is I magnetizing. Let us complete this circuit. From here I will put one line. This one is your V1, voltage applied across the primary winding. So I1 is the current taken from the supply. This is your I0 and this is your I2 dash now. Right? What is this? This is your R1, this is your X1. Now I will add further to this the secondary side impedance referred to the primary side. So this is your R2 dash, this is your X2 dash, and now let us draw the load. Right. So this is your load. Voltage across load is nothing but your V2 dash. So when my R2 is transferred to the primary side, it will become R2 dash, which is equals to R2 by K square. When I am transferring X2 to the primary side, it will become X2 dash, which is equals to X2 by K square. When I am transferring load impedance ZL on the primary side, it will become ZL dash, which is equals to ZL by K square. When I am transferring V2 on the primary side, it will become V2 dash, which is equals to V2 upon K. Right? Similarly, this is your I2 dash, which is nothing but K into I2. So this I2 dash will come back from this up to there. This is your I0, and vector sum of your I0 and I2 dash is again I1. So what we have done in this circuit, we have shifted this shunt branch on the input side. So if I am shifting this shunt branch on the input side, what is there? It will introduce a small error, and that error we have to neglect. What type of error? We have to neglect the drop in the primary leakage impedance, which will cause due to the no load current, because this no load current is also flowing through the R1 and X1. Now that drop we have eliminated. So it will introduce a small error. So that error we have to neglect. Why? Because the no load current of the transformer is only about 3 to 5% of the full load primary current. So the error involved by the use of such circuit is insignificant when we consider the behavior of the transformer on the full load, and hence this circuit is called as the approximate equivalent circuit of the transformer. Student, there is one advantage of shifting this shunt circuit on the input side. What is that? When we are shifting the shunt circuit, which is consisting of your R0 and X0 to the input terminals, then I can combine the primary and secondary resistance and reactance, and further I can reduce this circuit. So if I combine the resistance R1 and R2 dash, and similarly X1 and X2 dash, my circuit again get reduced as shown in figure. Then again let us draw this circuit. So again I will draw this circuit by combining the resistances, because these are nothing but they are connected in the series. So let us draw this circuit again. This is the voltage applied across the primary winding V1. This is your load. Voltage across your load is nothing but V2 dash, which is nothing but V2 by K again. Now see what I have done. I have added R1 and R2 dash. So let us, R1 plus R2 dash is nothing but RT1, means total resistance of the transformer referred to the primary side. Total resistance of the transformer referred to the primary side. So RT1 I can write down as R1 plus, what is your R2 dash? R2 dash is nothing but R2 upon K square. Right? So this is your RT1. Similarly, I have combined X1 and X2 dash. So combination of your X1 and X2 dash is nothing but, let it is denoted by XT1. XT1 is nothing but total leakage reactance of the transformer referred to the primary side. So what is your XT1? XT1 is nothing but X1 plus X2 dash. What is X2 dash? X2 dash is nothing but X2 by K square. X2 by K square. So you will get another equation. So X1 plus X2 dash by K square, you will get the XT1. So I have written here it as a XT1, right? So again I have forgot to draw the branch. Again I will draw one branch here, shunt circuit. So we will complete this approximate equivalent circuit now. This is your R0. This is your X0. And what is this? This is nothing but I0. What is this current? I2 dash. Current taken from supply I1. Right? And this is your V2 dash. So likewise we have drawn the approximate equivalent circuit of the transformer. So the total effective resistance of the transformer referred to primary side is RT1, which is nothing but R1 plus R2 dash or R1 plus R2 by K square. And the total effective leakage reactance of the transformer referred to primary side denoted by XT1, which is equals to X1 plus X2 upon K square or X2 dash. Now students, for studying the effect of the load on the secondary terminal voltage, the equivalent circuit is frequently further simplified by dropping all together the shunt circuit, which is consisting of your R0 and X0. So I will now drop the circuit, shunt circuit, from this approximate equivalent circuit, and we will substitute the primary current I1 for I2 dash directly. So let us draw this circuit again. Equivalent circuit further simplified by neglecting the shunt branch, which is consisting of your R0 and X0. So further we will draw this circuit as follows. Now what is this? This one is your RT1. This is your XT1, right? Then now let us connect load across this. This is your load. ZL dash, which is transferred to the primary side. Voltage across this is nothing but your V2 dash, which is equals to V2 by K. This is your primary side across which V1 is impressed. And current taken from the supply is your I1. Right? So what we have done for studying the effect of the load on the secondary terminal voltage from the above equivalent circuit, I have dropped the shunt circuit, which is consisting of R0 and X0, and I have substituted the primary current I1 for I2 dash as shown in the figure. Right? So this is the approximate equivalent circuit of the transformer that we get. Approximate equivalent circuit of the transformer. As we have transferred the secondary side quantities on the primary side, in the same way we can transfer the primary side quantities on the secondary side. So alternatively, after transferring all the primary quantities to the secondary side and proceeding exactly in the same manner as we have discussed previously, we can develop the equivalent circuit of the transformer referred to secondary side also. So when I am transferring the equivalent circuit, transferring the primary quantities on the secondary side, then I will modify this circuit as follows. So this circuit that I have taught you previously, it is referred to the primary side. Right? Now I will draw the approximate equivalent circuit of the transformer referred to the secondary side. Means I am transferring all the primary quantities on the secondary side. So let us draw this circuit. I hope all of you are understanding this. This is your voltage impressed across the primary winding. Sorry. Now, when V1 is transferred to the secondary side, it will become V1 dash, which is equals to K into V1. V2 I am not transferring, so I will write down V2 as it is. I am not transferring the ZL, that is load impedance, so ZL as it is. Now this will become RT2 and this will become XT2. What is RT2? RT2 is nothing but equivalent resistance or total resistance, of transformer referred to secondary side. So what is RT2? RT2 is nothing but R2 plus R1 dash, means resistance of secondary winding plus resistance of primary winding referred to the secondary side. If we proceed in the similar way, we will get this R1 dash as K square into R1. So your RT2 equals to R2 plus K square into R1, right? This is your I2 here. This is your I2 because we have drawn this circuit referred to the secondary side and not I1. In the similar way of your RT2, I can write down XT2 is equal to X2 plus primary leakage reactance referred to the secondary side. So if we proceed in the similar way, we will get X1 dash equals to X1 into K square or K square into X1. So your XT1 is equal to X2 plus X1 into K square. X1 into K square. Where K square R1, this K square R1 and X square X1 K square or K square X1 are equivalent resistance and reactance of the primary winding referred to the secondary side respectively. Thus, student, it should be remembered that when the primary resistance and leakage reactance and corresponding impedances are to be referred to the secondary side, each parameter must be multiplied by K square. Similarly, when secondary resistance or leakage reactance and the corresponding impedances are to be transferred to the primary side, each parameter should be divided by K square. And in this way, we can deduce the approximate equivalent circuit of the transformer. So this is the approximate equivalent circuit of the transformer referred to secondary side. Here 2 stands for refer to secondary. 2 stands for refer to secondary. Here 1 stands for refer to the primary. Means this is the approximate equivalent circuit of the transformer refer to the primary side. This is the equivalent circuit of the transformer refer to the secondary side. Right? So in this way we have completed the equivalent circuit, reduction of the equivalent circuit of the transformer in this lecture. So in next lecture we will see that what is the regulation of the transformer, how to find out the regulation of the transformer from the various tests as well as from the approximate equivalent circuit of the transformer. So thank you student. If you like this lecture, please don't forget to like, share and subscribe my YouTube channel. Thanks once again. Thank you.